Alright, sorry guys for the interruption. Alright, so yes, the solutions are part of the original. Alright? Because I'm using the distributive property. Should your four values also be the solution to the inequality 4x plus x squared is greater than or equal to 5? Explain why or why not. And are they? Well, guys, look, what have I done? All I've done is switched the 4x and the x squared. I've used what property? I've used the commutative property to rearrange the terms on the left-hand side. So yes, the terms on the left were rearranged by using the commutative property. Should your four values also be the solution to the inequality 4x plus x squared minus 6 is greater than or equal to -1? Well, look and see what changed. I subtract 6 from this side. What did I do to the other side? I subtracted 6. So should my answers be part of the solutions for this new inequality? Yes, they should, because 6 was subtracted from both sides of the inequality. And since I subtracted 6 from both sides of the inequality, I did not change my value. Okay? Should your four values also be the solution to the inequality 12x plus 3x squared is greater than or equal to 15? Once again, look and see what's changed. I went from x squared to 3x squared, 4x to 12x, and 5 to 15. All I did was multiply everything by 3. All right, both sides were multiplied by 3. So therefore, my solution should not change. All right? Just like all of our previous work on equations, rewriting an inequality using the commutative, associative, or distributive properties of real numbers does not change the solution set of that inequality. All right? Remember, when we're talking about inequalities, we are talking about, when you see the word inequality, we are talking about greater than, less than, greater than or equal to, or less than or equal to. Okay? All right, let's look at our example. Example number 1 says, what is the solution set to the inequality 5q plus 10 is greater than 20? Express the solution set in words, in set notation, and graphically on a number line. All right, so we're going to solve this inequality. Remember, commutative, associative, and distributive properties are the only properties that we know that do not affect the solution set. Alright, so how would I solve this? So I have 5q plus 10 is greater than 20. I am going to solve it just like I would an equation. Alright, I'm going to subtract 10 from both sides, and I get 5q is greater than 10. Then I'm going to divide both sides by 5. Q is greater than 2. So it says to express this in words. So Q can be, listen to the words that I use, can be any value that is more than 2. I'm no longer looking at that it's equal to. I'm looking at that Q can be any value that is more than 2. So in other words, 3, 4, 5, 6, 7, 8, 9, 10, whatever. All right? Express it in set notation. Here's my set notation. Q is greater than 2. And it says to express it in graphical, express it graphically. So let's look at this. Remember, open circle means it's not included. Closed circle means it is included. Q is not, or 2 is not included. Alright, so not included would be greater than, less than. If it is greater than and equal to, or less than or equal to, it would be included. Just a couple little notes there. So I'm going to put an open circle at 2. And then I'm going to shade everything that is bigger than 2. Okay. Alright, let's look at exercise 2. Find the solution set for each inequality. Express the solution in set notation and graphically on the number line. Alright, so I'm going to solve this just like I would an equation. Subtract 4 from both sides. X is less than 3, less than or equal to 3. So there's my set notation. I'm going to do graphically. Notice it is included, so I'm going to put a closed circle at 3. And I need to shade everything that is less than 3. So I'm going to shade this way. Looking at this here, you got to figure out which way you want to go about solving this. Here's what I would do. Says, now I need to look at this because it says m divided by 3 plus 8 is not equal to 9. Okay? So, I would subtract my 8. I have m divided by 3 is equal to 1. Now I'm going to divide everything by 3. Those cancel out, and I get m is not equal to 3. So now how would I graph that? Well, if it says m is not equal to 3, then that means it can be any other number. So I'm going to, because it cannot be 3, I'm going to put an open circle at 3. And then I'm going to shade everything that's bigger than 3 and everything that is smaller than 3. Okay? Let's look at this one. Just like solving a two-step equation. I'm going to subtract my 4. I get 8y is less than 7y minus 6. Subtract your 7y. Y is less than negative 6. Alright. Now I'm going to draw out my graph. And notice my graphs change. Alright, so it is not included. So I'm going to put an open circle at negative 6. And I want to shade everything that is smaller than negative 6. So I'm going to shade it this way. All right, let's look at D. I actually have to use the distributive property to figure this out. So 6x minus 30 is greater than or equal to 30. Add 30 to both sides. I get 6x is greater than or equal to 60. Divide by 6. X is greater than or equal to 10. Alright. That's my set notation. Let's do graphically. And I'm going to start like this on my graph. Just simply, I don't want to draw a huge graph. 10 is included, so it's a closed circle. And I'm going to shade everything greater than 10. Use my distributive property. 4x minus 12 is greater than 2x minus 4. I'm going to add 12 to both sides. 4x is greater than 2x plus 8. Subtract my 2x. I get 2x is greater than 8. Divide by 2. X is greater than 4. Alright, draw my graph. Four is not included, so open circle. And I'm going to shade everything that is greater than 4. Alright. Alright, let's look at exercise 3. Recall the discussion on all the strange ideas for what could be done to both sides of an equation. Let's explore some of the same issues here, but with inequalities. Recall in this lesson we have established that adding or subtracting and multiplying through by positive quantities does not change the solution set of an inequality. We've made no comment about other operations. Guys, right here, this sentence is very important. Adding or subtracting or multiplying with positive quantities does not change the solution set. Okay? We have made no comments about other operations. So let's talk about what happens when we square something. Do b is less than or equal to 6 and b squared is less than or equal to 36 have the same solution set? If not, give an example of a number that is in one solution set but not the other. Alright, so let's look at this. So in the first inequality, b can equal 6 or any other number smaller. Alright? So in the first inequality, b, make that a capital B since that's capital B. Capital B can equal 6 or any other number smaller. Okay, so we've made sense of what that inequality is telling us. Let's look at b squared is less than or equal to 36. Now, when I am doing this, I have to do the square root. And squaring is a little bit different. So if I take the square root of b squared, I get b. If I take the square root of 36, I get negative 6 or positive 6. So the second inequality is a little different. Because I can say, in the second inequality, b can be less than or equal to 6, or b can be greater than or equal to negative 6. Alright, because when I take the square root of 36, I can get 6 or negative 6, my inequalities change a little bit. So now it's telling me that B can only be somewhere between 6 and negative 6. And it can include 6 and negative 6. So do they have the same solution set? No, they do not have the same solution set. So it says give an example of a number that is in one solution set but not the other. So 7, I'm sorry, not 7. I need a number that is smaller than 6, but is not between 6 and negative 6. So actually I could have said negative 7 would be in both solution sets. All right? Multiplying 3 by a negative number. Do 5 minus c is greater than 2 and negative 5 plus c is greater than negative 2 have the same solution set? If not, give an example of a number that is in one solution set but not the other. Well, let's solve these. So 5 minus c is greater than 2. If I subtract 5 from both sides, I have negative c is greater than negative 3. I have to divide by a negative 1. When I divide by a negative number, my inequality sign changes. So c is less than 3. Let's look at this one. All they did was multiply by a negative 1 through and change my inequality. So let's add 5 to both sides, and I get c is greater than 3. So do they have the same solution set? No, they do not have the same solution set. Because here c has to be less than 3. Here c has to be greater than 3. All right? When you multiply by a negative number, when you multiply or divide by a negative number, the inequality sign flips. Okay? Bonzo's ignoring exponents. Do y squared is less than 5 squared and y is less than 5 have the same solution set? We've already talked about this. No, they do not. Okay? Because here, I can have 5 or negative 5. Here, it's just 5. So they do not. All right, example number 2. JoJo was asked to solve 6x plus 12 is less than 3x plus 6 for x. She answered as follows. 6x plus 12 is less than 3x plus 6. So she says, I'm going to pull out a 6 and use the distributive property. And then I'm going to pull out a 3. And she says 6 is less than 3. Multiply through by, and she got rid of that x plus 2. Since the final line is a false statement, she deduced that there is no solution to this inequality, that the solution set is empty. What is the solution set for 6x plus 12 is less than 3x plus 6? She says that this is not right and that there actually is no solution. Let's see. So I'm going to subtract 12 from both sides. So I get 6x is less than 3x minus 6. I'm going to subtract 3x from both sides, and I get 3x is less than negative 6. Divide by 3, and I get x is less than negative 2. That is the solution. Explain why JoJo came to an erroneous conclusion. Why did she make an error? Why is her solution not correct? Well, she multiplied through by 1 over x plus 2, and that's dangerous. We don't know whether or not that's a positive or a negative. Its value depends on the value that you choose to assign to the variable. So we could be multiplying through by a negative value, making that step invalid. All right? So not knowing if 1 over x plus 2 is positive or negative, makes this wrong. All right? It depends on whatever value I put in for x. All right. In the last exercise, we saw that both sides were multiplied by negative 1. The solution set of the inequality changed. So we can't multiply through by negative 1, as this does not match the operations given by the properties of inequalities. All right? So let's just kind of look at example number 3. Solve negative q is less or is greater than or equal to negative 7. Solve for q. All right, so here's what I can do. I can take the negative q over. Let me rewrite my problem here. I'm going to add q to both sides. And I get 0 is less than or equal to negative 7 plus q. I'm going to add 7 to both sides, and I get 7 is greater than or equal to q, which tells me that q, and I'm going to rewrite this, is less than or equal to 7. Okay? Let me show you another way that you can do this. We never want our q or our x to be negative, so I'm going to divide by negative 1. Remember what I said, when I divide by a negative number, my inequality sign changes. Negative 7 divided by negative 1 is positive 7. And look, guys, we got the same answer. All right, we got the same answer there. All right, find the solution set to each inequality, express the solution set in set notation, and graphically on the number line. All right, we're going to divide by negative 2. So F, my sign changes because I'm dividing by a negative number. Negative 16 divided by negative 2 is 8. So F is greater than 8. Open circle at 8, and I'm going to shade everything bigger than 8. All right, let's look at this. I've got negative x over 12 is less than or equal to 1/4. I'm going to multiply through by a negative 12. So I get x, my sign changes. Negative 12 over 4 is negative 3. So x is greater than or equal to negative 3. So negative 3 is included. So I'm going to shade it this way. Alright, take your 6 over, subtract 6. Negative a is greater than or equal to 9. Divide by negative 1. So a is less than or equal to negative 9. Close circle and shade everything less than negative 9. Alright, let's look at the last problem. Sorry guys, that's my alarm for our bells. Alright, let's look at the last problem. Do your distributive property. Negative 6x minus 12 is greater than 0. Take your 12 over. Negative 6x is greater than 12. Divide by negative 6. X, flip your sign, is less than negative 2. Open circle at negative 2. And shade everything less than negative 2. So recall the properties of inequality. Take a minute to make sure you read through that. And let's go ahead and look at this. Use the properties of inequality to show that each of the following are true. So if P is greater than or equal to Q, then negative P is greater or is less than or equal to negative Q. What did I do there? I multiplied through, or you could say you subtracted Q. Alright. We'll just kind of run through these. We're not going to spend a whole lot of time on these. So P is greater than or equal to Q. I'm going to subtract Q from both sides. So I get P minus Q is greater than or equal to 0. Alright? Because I just want to get I need a negative Q. I'm going to subtract P from both sides. So now I get negative Q is greater than or equal to negative P. And that's exactly what we set up here. Negative Q is greater than or equal to negative P, or negative P is less than or equal to negative Q. Alright? Let's see. We're going to X out B, and let's go on. We're going to X out C, and we're going to X out D. Let's go to exercise 6. Solve negative 4 plus 2t minus 14 minus 18t is greater than negative 6 minus 100t for t in 2 different ways. First without ever multiplying through by a negative number, and then by first multiplying through by negative 1/2. Guys, at this point in time, I really just want you to be able to solve these. So let's look at how we're going to solve it. Go ahead and combine your like terms. So I have negative 18 minus 16t is greater than negative 6 minus 100t. I'm going to add 100 to both sides. Alright, because I want to get my t to be positive. So I have negative 18 plus, because my 100 is greater, plus 84t is greater than negative 6. Add 18 to both sides. 84t is greater than 12. Divide by 84. T is greater than 12 over 84, which actually reduces because 12 will go into 84, so T is greater than 1 over 7. All right? Let's look at the last problem. Like I said, I'm at the point that I'd much rather just know that you can solve these. So negative x over 4 plus 8 is less than 1/2. I would go ahead and multiply through by a common denominator. So I'm going to multiply everything by 4. When I do that, I get negative x plus 32 is less than, 2 goes into 4 2 times. 2 times 1 is 2. Alright, now I can solve. Negative 32, subtract. Negative x is less than negative 30. I have to divide by negative 1, so x is greater than 30. Alright, make sure you complete this packet. You will turn that back into me, and then you will have work for the rest of the week that goes along with this lesson.